Okay, let's have a quick review of perimeter and area for all these figure types so you can use them. Okay, the perimeter is the lengths of the sides all the way around. Sum up the lengths of the sides. So here for a square, you are saying the side length 4 times since they're all the same, so the perimeter is 4 times S. Okay, for the rectangle, you've got 2 base sides and 2 height sides, so you say 2 times the length of the base plus 2 times the base of the height. Or you could say the base plus the height and then add them together and double it. For a triangle, you have to get those 3 measures and just add them together, and you might need to calculate them if you're in the coordinate plane. And for a circle, we call the perimeter the circumference, okay? So you're saying pi times the diameter. Another way of saying it is 2 times pi times the radius, because the radius times 2 is the diameter. So this d here goes with this 2r here, okay? What about the area? Well, for a square, you're doing side times side, so side squared. Since they're the same measure, you just do the same number twice. For a triangle, it is 1/2 base times height. And you can see that because if you filled out this into a rectangle, you'd have exactly twice as much area as you have when it's just a triangle. Okay, but that rectangle would have the same height and base. So since you're having half of that amount, and draw it, and actually I can do that right here for you. If you drew that rectangle and like that, I don't know if you can see that, it would be essentially half of the entire space. Okay. For a rectangle, you do base times height, and for a circle, the formula for the area is pi times the length of the radius squared. And if you were given the diameter, you would have to cut in half if you were finding the area. Okay, so let's apply all that. Okay, and this is just a note that when we're doing lengths like perimeter and circumference, we just have the units themselves: inches, feet, yards, miles, centimeters, meters. But when you're measuring area, you are essentially covering up a flat space, a surface, right, inside. And so you can't cover it with lengths because they're infinitely thin. So what you need to do is you need to take units in squares, right? Like 1 inch by 1 inch square, and see how many of those squares cover it. So square units, square inches, square feet, etc. Okay, and if it's a circle, of course, you're not going to fit perfect squares in there. What you're going to do is you're going to say what would be the equivalent number of square units that would cover this perfectly with no overlap. Okay, so let's apply it. All right, so what are we finding here? We're finding the perimeter of the rectangle. They're designing a rectangular garden for the courtyard of their school. Here's the drawing over here and the illustration, and they plan to place edging on the outside. How much edging material will they need? Well, we need to find out what is the edge or the perimeter of this figure. What are we going to do? Okay. It's helpful to say, okay, here's the garden, and let's draw it out. If we have it drawn out with 16 by 22 garden, and then we want to add another 4 feet here, we will draw it. And you see that when you draw it out, and this is what it says here, it's really helpful to be able to picture the larger space around, all the way around, by drawing this diagram. And you can see that the path, because they're putting 4 feet of edging, the path is actually adding 4 feet on this side and this side. So this length here goes from being 16 with an extra 4 feet here and here to 24 across the full top right here. And then same thing down here. This was 22, but they've got a 4-foot path here and a 4-foot path here. And so 22 plus 4 plus the other 4 is 30. So now we've got this larger rectangle that is a 24 by 30 rectangle. Okay, so what are we going to do to find the perimeter of that? Well, we always do, right, twice the base plus twice the height, because we have that base twice and that height twice. Okay, and we plug in those numbers and we find out that we need 108 feet of edging material. And the big trick here is to see that if you have a 4-foot path, you're adding 4 foot on this side and on this side as well. So you add 8 feet to that length, and you add 8 feet total to that length as well. Okay? So try this got it problem. Oops, sorry. Okay, good luck. Okay, so a little notation about circles. You're going to name them by the point that is at their center. So if it has center A, you're going to write it as this with a circle with a dot inside and A. Okay, so um, you're going to use pi in your calculations with circles, and you probably already know that. Pi is an irrational number, and so you can never write it completely. You can't, it doesn't have repeating decimals and it doesn't end. So you estimate it with either 3.14 or 22 sevenths. And of course, your calculator also has a button for pi if you have a calculator, and you can then type it and round off to whatever decimal they tell you. But if they tell you to write it in terms of pi, what they mean is this. If you have a circle with a radius of, let's say, 7, then, and the formula for area of a circle is area equals pi times the radius squared. Okay, then you would say, okay, that's got a radius of 7, so it's pi times 7 squared, and what you get is 49 times the value pi, which if you're going to give the area exactly, you're going to give it by saying the area is 49 times pi. And just fun fact, this is a little more than 3, so if you take this amount a little more than 3 times, you're going to get about 150. So this is not actually 49 units squared for the area. It's closer to 150 square units, and that's because this is worth a little more than 3. So just be aware of that. But that's what it means to write it in terms of pi. Okay, we're looking for circumference here, and it says, what's the circumference of the circle in terms of pi for the first one? And here's the first one. You can see the circle, and here's the problem. What is the circumference of this? Well, circle M here. By the way, look, if you look up here in the corner, what's written is it says, how do you know which formula to use? Do you want to use pi times diameter or pi 2 times pi times r? Well, what are we given? We're given the diameter, so you're going to use the one that involves diameter. Okay, so circumference equals pi times diameter. And what do we know the diameter to be? 15. Okay, so the exact answer is 15 pi, whatever units, in this case, inches. It's a measure of length, so it's not inches squared, it's just inches. So that's exact, but if you were to type this in your calculator and then round it off to the nearest something or other, then you would, oh, here they say to the nearest tenth, then rounding this to the nearest tenth is about 47.1 inches. So it is 15 pi inches for the exact value in terms of pi, and when it's rounded to the nearest tenth, it's about 47.1 inches. What about this next one? Okay, for t. Now, again, where you have, in this time, we have the radius and not the diameter, so we want to pick the one that says 2 pi r. So we do circumference equals 2 pi r, we plug in the radius, which is 4, and we multiply 2 times 4 is 8, so 8 pi, that's the exact answer in terms of pi. And if we were to multiply by pi on the calculator and then round off to the nearest tenth, we would get about 25.1, and the units are centimeters, and its length since it's circumference, so the units 25.1 centimeters. Okay, try the got it problem. Okay, what if we're finding perimeter in the coordinate plane? So here's what we need to do. Uh, we need to find the perimeter of the figure, and what that means is that we need to find all the side lengths. Since it's a triangle, you add up all the 3 side lengths. And how do you do that? Well, 2 of them are right along the grid lines. like this, okay? And these are essentially like number lines. You've got a value here of -2. You can see that the y value, the y coordinate is -2, and this y coordinate is 6, right? This x coordinate is -3, this x coordinate is 3. So what does that look like here? You can see that what they're doing here is they're finding the length of EF here by saying 6 minus -2. Okay, this is the ruler postulate where you subtract the two, uh, the places where the endpoints are, right? The values at the endpoints. So 6 minus -2 is 8, so that's got a length of 8. Here we do 3 minus -3. You can go either way. If you did it the other way, you'd get a -6 in there, and then you would still get a 6 when you did the absolute value. So this has the length of 6. You could certainly count it, but we have a rule for this that's it's better to understand this and do that, because then you're not going to miscount. You have the numbers and you'll subtract. What do you do for a diagonal? Well, in the coordinate plane, remember, you're going to be doing the distance formula to find these 2 points. And so you take the coordinates here and here, and you do x2 minus x1 squared, and then y2 minus y1 squared, and then square root the whole thing when you add them together. And when you do that, you find 10. So you have to sum up these sides. You've got 6, 8, and we found this one is 10. So 8 plus 6 plus 10 is 24, and the perimeter of this is 24 units. Here's your got it problem. Okay, now this example might seem a little intimidating until you follow it through to the end. And you certainly need to know how to convert units in order to do it. But here's the instructions. You're finding the area of this banner for the San Francisco Arts. Um, you want to make a rectangular banner that's similar to the one on the right. The banner shown is 2.5 feet wide and 5 feet high. And to the nearest square yard, notice they're giving it to you in feet, but you want it to the nearest square yard. How much material do you need? So we really want to convert these to the units that we want to be using. So that's what they're going to suggest that you do. And again, your problem will be slightly less tricky, but watch what you're doing here. Okay? They're going to take the 2.5 feet, which you can write as 5/2 feet. Yeah? They're going to use this conversion. This is how you do a conversion. If you're having feet and you want to turn it to yards, you put the unit you want to turn it to on top, the unit you're converting it from on the bottom, feet to yards. So, and you have the same equal amounts. 1 yard equals 3 feet, right? So then feet on the top and feet on the bottom cancels, leaving you with yards. So that's the idea behind converting units, and you should have done that in Algebra 1. Now, 5/2 times 1/3, 5 times 1 is 5, 2 times 3 is 6, so you get 5/6 of a yard for that measurement, okay? And for this one, you have 5 feet high. How do we convert that to yards? Well, we say we're converting from feet into yards, so feet goes on the bottom to cancel, yards goes on top, and 1 yard is equal to 3 feet, so you put 1 yard equals 3 feet. Cancel the feet, 5 times 1 is 5, and then this is like over 1, right? So 1 times 3 is 3, and you get that. So what do you do to find a rectangle? You do base times height, so you're going to do 5/6 of a yard times 5/3 of a yard, and multiply them together. 5 times 5 is 25, 6 times 3 is 18, and you can actually just turn this into a mixed number. So 1 7/18 square yards, because remember, you didn't only just multiply these numbers, you also multiplied yards times yards. And anything times itself is that thing squared. Okay? And the question is, how many, to the nearest square yard, how much material do you need? And since you obviously have to round up, you can't buy 1 yard, that's not going to be enough, so you have to, or 1 square yard, so you have to buy 2 square yards. Okay? Yours is probably slightly more doable. Check it out. Here's your got it problem. Okay, and we want to find the area of the circle in terms of pi, which means we don't actually need to calculate the value of pi as an estimate. But what we do need to know is what the formula for area of a circle is. That's pi r squared. And do we have the radius? No, we have the diameter. So the radius is half of that, or 8 meters. So let's check it out what they do. Okay, they point out here that the radius is half of the diameter, so 8, and then they use area equals pi r squared. R times itself is 64, and that's times pi because we're keeping it in terms of pi. So 64 pi, and what are the units? Well, if it's meters and we're doing area, it's those units squared, so meters squared. 64 pi meters squared. Here's your got it problems. All right, well, we've had this postulate that it really is helpful when we're looking at irregular shapes and we want to find the area. If we're looking for the area of a region that is irregular, we can split it up into regular figures that we know how to find the area of that have non-overlapping parts. So we're not missing any parts and we're not counting anything twice. Okay, so here's the problem. What's the area of the figure at the right? And here is the figure at the right. And we can see those measurements. We've got the 9 centimeter side, we've got a 3 centimeter side, and then we have all these segment marks that show that we have also 9 here, also 3 on each of these sides. Okay, so what are we going to do? We can split this up like this, separate it into rectangles rather. Okay, and since this is 3 and this is 3, we've got a 3 by 3 rectangle right there. Okay, this whole thing is 9. But you can see it says that they're all right angles, so we know that if this is 3 here, we can go down here, and we got a square here. Okay, this is 3, so we can continue that across, and it makes sense because this is 3 as well, and so is this. 3, 3, 3 is 9. Now, just to be aware, there's another way you could think about this would be to fill it in as a 9 by 9 rectangle, and then we could subtract away these particular rectangles that we have here. But that's one way you could do it, but we're going to follow through on the original idea that we came up with here, which is to just split it into pieces. Okay? And what do we do from there? Well, from there we just find the area of each portion. And the area of this one is 9, the area of this one is 18, and the area of this one is 27. So when we sum them all together, we get 54. And remember, if it is centimeters times centimeters, it is centimeters squared, right? Something times itself is that thing squared. So 54 centimeters squared, and the correct choice here then is D. Yeah? And here's your got it problem. This is your figure. And yeah, give it a shot, see how you do. All right, try this lesson check. Good luck.